Which of the following equations relates y to x for the values in the table above? The first question we need to ask is, as x increases by 1, are we adding something to y or multiplying y by something? And it looks like we are adding 14 fourths to y with each term. And so this is going to be a linear equation with a slope of 7 halves, and so that's D. The first term in a sequence is 9. Each term after the first is 4 times the preceding term. If w represents the nth term of the sequence, which equation gives w in terms of n? When n is 1, w needs to be 9, and the only answer choice that accomplishes that is D. In the xy plane, the graph of a linear equation of the form y is equal to mx plus b and the graph of an exponential equation of the form y is equal to ab to the x both contain points 1, 3, and 2, 4. If the point rs is on the graph of the linear equation and the point rt is on the graph of the exponential equation, where r is greater than 0 but less than 4 and s is greater than t, which of the following must be true? All this talk about r's and s's and t's is just a fancy way of asking for what values of x is the linear function greater than the exponential function. The conventional way of finding this is to use the 2 points to solve for the two equations, and then use Desmos to see where the linear function is greater. So let's start with that. We have that the slope of the linear equation is y2 minus y1 over x2 minus x1, which comes out to 1. We can then use the y is equal to mx plus b equation with the point 1, 3 to get our y-intercept, and that's 2. So the linear equation is y is equal to x plus 2. For the exponential equation, we'll start with y is equal to a times b to the x, and again plug in our 2 points. That gives us 3 is equal to ab, and 4 is equal to ab squared. Notice that the second equation can be written as 4 is equal to ab times b, which allows us to make a substitution for b using the first equation. Then we get b is equal to 4 thirds. Plugging b into the first equation, we have that a is equal to 9 fourths. So the exponential equation is y is equal to 9 fourths times 4 thirds to the x. When we plug these two into Desmos, we see that the linear function is greater than the exponential function between 1 and 2, so the answer is B. Now, I wouldn't have done it this way on the exam. This approach took a long time because we found more information than we needed. Instead, I would have sketched a similar picture, only without knowing the specific equations. Knowing the general shape of each function is good enough. I would have recognized that exponential functions with positive leading coefficients are always concave up. So if a line and an exponential function share 2 points, the linear function will be greater than the exponential function between those points. For x greater than 0, the function f is defined as f of x equals 201% of x. Which of the following could describe this function? Now this is tricky because when we see a percentage sign in a function, we typically think exponential equation. But in this case, the question doesn't say as x increases by 1, f of x increases by 201%. It says that f of x is equal to 2.01x, which is an increasing linear function. Which of the following describes an exponential relationship between the pair of variables listed? A. For every 3 millimeter increase m in the thickness of a piece of glass, the intensity of light I traveling through the glass decreases by 20%. As we add a fixed amount to m, namely 3, we multiply I by a fixed amount, namely 0.8, so this is indeed exponential. Now, I can tell that a lot of you are not going to like that 3, so I challenge you to find the percentage decrease as m increases by 1 millimeter. And the answer is not 20 over 3. We have that I is equal to some constant times 0.8 to the m over 3, and if we push in that 1/3, we get a times about 0.928 to the m, and that means that when m increases by 1 millimeter, I decreases by about 7.2%. A photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equations models the number of sheets of paper P remaining in the machine m minutes after the machine started printing? It's tempting to see that 30% and think of exponential equations, but this question does not say that every 20 minutes the amount of paper decreases by 30%. It says that the machine copies at a constant rate, and in those first 20 minutes, 30% of the 5,000 sheets are used. And so we have that 1,500 sheets are used in 20 minutes, which means that 75 sheets per minute is the rate of decrease in this linear equation, so the answer is B. Alright gang, this was just the appetizer. For the main course on exponential equations, head over to my next video here. I will see you there.